This is your lecture for 4.5. Okay? In this lecture, we're going to talk exponential growth and decay. So your general form of the equation is A equals A sub 0, which is your original amount, e to the kt. And your k is kind of like it was with the variation in chapter 3. It's a constant once you find it. If the exponent is positive or greater than 0, that function is growing. If it's negative, it's decaying or declining, okay? So, writing my formula up here. Okay. In 1970, the population was 203.3 million. By 2010, it was 308.7. Okay? So what do I know? I know that my A sub 0, or my original, was 203.3. 2010 from 1970 tells me 40 years has elapsed. After 40 years, my A is 308.7 million. Oop. That's my point in the wrong place there, huh, guys? So I need to find K so I can write my equation. My equation is going to look like A equals, I know my original is 203.3 E, but I don't know my K. And then you're going to have your T up here. So I've got to find K using the information they give me. So plugging in what they give me, 308.7 equals 203.3 E to the 40K. Divide both sides by 203.3. I wouldn't actually divide it and round it until the very end. Okay? So now I have 308.7 over 203.3 equals E to the 40K. Remember, when you have an E here, you want to do the natural log of both sides. So, natural log of 308.7 over 203.3 equals the natural log of E to the 40K. But remember, these cancel. So now I have the natural log of 308.7 over 203.3 equals 40K. Dividing by 40, I will get K. So I need to plug this expression into the calculator. Okay? Because I have K equals natural log of 308.7 over 203.3 divided by 40, which is approximately, let's see, natural log 308.7 divided by 203.3, close the parenthesis, and then divide that by 40. I get approximately 0.01. And there you found your equation. So now when we go to part B, 203.3, it says, by what year will the population reach 335 million? So now you're taking the equation you just found, okay, and you're plugging 335 in for A. Divide both sides by 203.3. So you have 335 over 203.3 equals e to the 0.01 t. Just like we did before, do the natural log of both sides. Okay? And remember again, the natural log of e cancels. So we have the natural log of 335 over 203.3 equals 0.01t. Divide by 0.01 on both sides, so t equals the natural log of 335 over 203.3 divided by 0.01. Punch that in your calculator, okay? Natural log of 335 divided by 203.3 divided by 0.01 335 divided by, I didn't like how I punched it in, 203.3 divided by 0.01 and I get approximately 50 U's. Okay, one more problem here. They give you your function right up here. Okay? And this is the number of people who became ill with influenza 2 weeks in a town with 30,000 inhabitants. So how many people became ill when the epidemic began? Well, when it began, 0 weeks had passed. So you're putting a 0 in place of t. Punch that in your calculator, but make sure, I put t there, but that's supposed to be 1.5 times 0. Make sure you put your parentheses around the bottom, okay? So approximately 1,429 people became ill when it began. How many by the end of the 4th week? So 30,000 over 1 plus 20 e raised to the negative 1.5 times 4. To the negative 1.5 times 4. And we get by that time, approximately 28,583 people are ill. What is the limiting size? Well, the population of the town is 30,000, so the limiting size is 30,000. And that ends the lecture for 4.5.